Hello, and welcome to today's webcast. NBASE-T Applications and Implementations of 2.5 and 5G in the Enterprise. The technical information in this webcast will be delivered by Peter Jones, Principal Engineer with Cisco. Peter will speak on behalf of Cisco today. He also serves as Chair of the NBASE-T Alliance. Information also will be delivered by Tom Kelly, Director of Business Development for Enterprise with Panduit. Panduit is also sponsoring this seminar. We thank them for making the seminar possible and thank Peter and Tom for the expertise that they will share today. Peter Jones will be today's first speaker. He will address topics including the evolution of Ethernet, where it's been, where it is, and where it's headed, as well as providing specific information about 2.5 and 5G BASE-T platforms and use cases. Tom Kelly will follow with a presentation focused on the twisted pair infrastructure supporting 2.5 and 5G BASE-T. He'll cover those speed impact on cabling performance, how to assess your cable plant for its ability to support 2.5 and 5G. He'll talk about mitigation strategies and also TIA standards projects that address these issues. Our speakers have a significant amount of information to provide to you today, so we'll deliver as much of it as we can in our scheduled time of 60 minutes. Please use the purple Q&A button at the bottom of your screen to submit questions for our speakers. We'll hold a Q&A with them as time permits at the end of the seminar. Also at the bottom of your screen, hit the green button to download a read-only copy of the slides that are being presented today. Again, it's that green button at the bottom that will give you access to your copy of the slides being presented today. For those who plan to obtain an attendance certificate from today's seminar, I will walk you through that process before we begin our Q&A session. So thank you very much for joining us today, and I'm pleased to turn it over to our first speaker, Peter Jones. Peter, whenever you're ready.
Thanks, Patrick. Hi, folks. I'd first like to thank Patrick and his organization for having me to speak, and also for Panduit for making this possible. My name is Peter Jones. I work as a system architect inside Cisco, and I work for the group that creates Catalyst 2K, 3K, and 4K series switches. And so my business is really in the campus. The other thing I do for a living is I chair the NBASE-T Alliance, and one of my key roles right now is advocating and evangelizing for 2.5 and 5G BASE-T. So let's get going. I'm seeing a white screen right now. Okay, that's good. So here's my agenda for the day. I'm going to talk a little bit about the evolution of Ethernet, because I think understanding where we've come from is very key to understanding where we're going to go in the future. I'll talk about 2.5 and 5G BASE-T, platforms and use cases, and I'll do a quick wrap up with some final thoughts. So, this picture is the first memo from Robert Metcalfe describing Ethernet. As you know, you can clearly see that what we would now call a cable here describes as the ether, which is where the Ethernet name comes from, and this is from 1973. Now, so what you think about how long Ethernet's been running. Now, Ethernet also started, the project by IEEE started as Project 802. Now, it was started in 1980, and so the name is actually, it was started in February, so it's Project 80 and the second month. And here's what Ethernet used to look like, right? It's the fat yellow cable, what everyone thinks originally is Ethernet. Right? This included vampire taps. It was an interesting piece of technology, great construction, but not all that user-friendly. The next thing we saw after Ethernet, over on the left-hand side of the screen, was what I used to call CheaperNet, right? With the BNC connectors. And I remember using this in my first network that I worked on. And it was sort of interesting because I was sitting at a desk and I could plug in some extra T pieces myself with BNC connectors, and my local network worked fine. Mind you, the guy on the other side of the building, his network may have stopped working then. And so this was a really interesting evolution from the thicknet into thinnet, but it wasn't that user-friendly. Then, of course, we headed into BASE-T. And I'd argue that BASE-T is where it became possible to build a really large network really efficiently with great user experience. So originally, Ethernet was based on CSMA-CD, right, Carrier Sense Multiple Access Inclusion Detect. But over the years, it's evolved over many, many types, over so many years and many speeds, and it continues to evolve. This deck is actually an extract of a deck I give for Cisco Live, and you guys may not know, But if you go to CiscoLive.com, you can get a free Cisco Live account, and then you can review all of these decks because they come both the decks are available as PDFs and they're also available as video. So if you'd like more about this session, which is part of a 1.5 hour session, head over to Cisco Live, get an account, and take a look at the video. Okay, I'm going to talk just for a little bit about the evolution of the BASE-T roadmap. As you guys know, BASE-T is how almost all of our campuses are attached. BASE-T's story started over in 1990 when we did 10 BASE-T on Category 3 cable. We evolved through 1999 where 1000 BASE-T, what we call GigE, was standardized for 100 meters on Category 5E. Now, I'm going to let you hold 1999 in your head for a second as I move on. We also had in 2006, we standardized 10G BASE-T at 100 meters of Category 6A. What's a little interesting as we go forward in time is we're now in 2016 and we're standardizing 2.5 and 5G BASE-T, and the goal is to get 100 meters on Category 5E and Category 6. And in the BASE-T world, this is the first time we've done a new speed on the previous cable plant. At the same time in 2016, we actually have 25G BASE-T and 40G BASE-T being standardized for 30 meters on Category 8. And I think now is the first time we have a real split between the technology focused on the enterprise access, which is 2.5 and 5G BASE-T, versus the one focused on the data center, which is the 25G and 40G BASE-T. So the key thing I want to think about here is that even though we standardized GigE in 1999 in Category 5E, we're now going back almost 16 years later to do 2.5 and 5G BASE-T on Cat 5e and Cat 6. So while you're holding that in your head, I also briefly want to talk about the wireless evolution. So back in early 2000, wireless was just new invented, and it was sort of a nice to have, very few clients, very low bandwidth, and the clients all looked like what you see in the bottom left-hand corner. It was basically computers. But as we evolve in towards 2016, wireless for many companies has become mission critical. It's how all of our people plug in. And they may plug in via a laptop, but more and more it's coming in through tablets and other mobile devices. At the same time, the clients have exploded and the bandwidth has exploded. So if I graph this in speed, in early 2000, we were looking at 11A and 11B. There's about 11 megabits a second. In 2013 we got 802.11 AC Wave 1, which topped out about a gigabit. And we're now starting to see the rollout of 11 AC Wave 2, which could be 3.5 or 6.8 gigabits at the far rate. And with future technologies like 802.11x, we're heading towards the 10 gigabit wireless. So I want you to think about that for a little bit, because back down in that bottom left-hand corner, when wireless was running at between 2 and 11 megabits a second, and there was almost none of it, that's when Gigabit Ethernet, 1000 BASE-T got standardized. And right now we're up here where wireless has moved from 11 megabits a second up to in the order of 5 gigabits a second. And that's really the area that we started to try and address with 2.5 and 5G BASE-T. How would we serve these types of devices, 11 AC Wave 2 devices, while preserving the way people currently build their networks? Okay, so why would we do 2.5 and 5G BASE-T? So between 2003 and 2013, we sold about 70 billion meters of Category 5E and Category 6 cable. If you think about it, that's about 10 meters of cable each. That is a huge, enormous investment. In the last 20 years, we sold more than 4 billion 1000 BASE-T, 100 BASE-T, and 1000 BASE-T switch ports. Right, this is the main market for how people connect to networks. The cool thing about BASE-T is it allows incremental upgrade of a system. Because BASE-T ports auto-negotiate, you don't have to rip and replace your entire network in one go. The existing specifications, and I'm really talking now about before 2014, supported only 1 gigabit a second over the cable, but we knew we could go faster. So our real job was to figure out what we could get, how could we get more value from that cabling investment. Because as we know, the cable is an integral part of how the building runs, and I need to get whatever I can out of that investment. Okay, so let me start talking about platforms and use cases. So Cisco's branding for this technology, we call it Cisco MultiGigabit Ethernet. So where did we start with? We started, and this is talking about products we're shipping today. I'll get to the product details in a second. So we're already compliant with 1000 BASE-T and 10G BASE-T IEEE standards. And Cisco is very heavily involved in driving the IEEE 802.3BZ, which is the 2.5 and 5G BASE-T standard. I personally am very active in that group. I led what's called the CFI that started the group, and also I serve as one of the ad hoc chairs. Okay, we also provide PoE, PoE Plus, and what we call UPoE. So that's 15 watts, 30 watts, and 60 watts. And so we're providing that on ports that support 60 watts of PoE over 10 NBASE-T. And our goal is to really enable new and different types of PD devices. If you look on the internet, you'll find Cisco has initiatives called Digital Ceiling, where we're looking at powering a whole range of devices in an enterprise of PoE. We wanted to support infrastructure investment protection. So we know that we have many of our customers already have a building and they don't get to recable on a regular basis. So we were really looking how to give people a speed upgrade on what they owned already. We are also talking in general about 6A cabling as being good if you build a new building, because we really want you to be building that new building for 10 to 15 years. I know Bob will talk more about, Tom will talk more about this later. And also when we considered APs, we really wanted to maintain the way you build an AP today, which is you get a single cable that provides you power and data. So we want to provide the changing rates, fast Ethernet, 100 meg, gig, 2.5, 5, and 10. And we wanted to make sure that we're future-proofed as the end devices, APs and other devices, evolve to higher speeds. So that's the core of what we've tried to produce and what we've already delivered to market. Okay, I'm going to quickly run through the products that we already have in the market today in the switches. We have the Catalyst 4500E. This is our modular access switch. We have a 48-port line card, which offers you 12 ports, what we call 12 ports of multi-gigabit, up to 96 ports of that in the system. So this is the switch over on the left-hand side there. In the middle is the Catalyst 3850. This is our stackable switch. We offer it in 24 and 48 ports. You get, what Cisco is doing right now is that we brand the ports which are multi-gigabit as the blue ports. You'll see them on the highlights. And these are stackable with our current set of 3850s. We offer a small switch we call the 3560CX. It's actually a fanless switch, and it's really intended for access extension. So this shows up in places like conference rooms, maybe in retail outlets. It shows up in casinos. It shows up in other places. So this is really a port expander. Okay, so the other thing that we have announced recently, but is shipping not quite yet, but real soon now, is the Cisco MultiGigabit AP3800. This is a very interesting AP. There's lots of material online. I'm not a wireless guy, so I'm not going to go in gory detail here. But the point I'll make to you is that we claim a combined data rate for this AP of 5.2 gigabits a second, and it supports multi-gigabit Ethernet at 1.5, 1 gig, 2.5, and 5. So this model will be hitting the market really soon. Okay, so where are we today? So this data is based on research we got from BizRia in December of 14 as part of the process towards getting our 3BZ up and running. And what we're finding is the installed base T cabling is dominated by 5E and 6. The red in this graph on the top right is category 5E. The blue is category 6, and the green is 6A. And what you basically find is 5E and 6 are about 90% of the market. If you look in detail on the numbers, you'll find that 5E is growing very slowly, 6 is doing well, 6A is growing well. But I think the reality is that if you see the legend in the top of that graph, right now we have about 1.4, at the end of 14 we had about 1.4 billion outlets. 1.3 billion of them are 5E and 6. So that is the market for which 2.5 and 5 GBASE-T is designed to address. So let's talk about Ethernet switch ports by speed. So this is the Deloro forecast from January of 16. What you find interesting here is that we are dominated today by gigabit. Even today you'll see we sell some 100 megabit, but dominated by gigabit. And that actually continues to be true out to 2020. So enterprise port types are dominated by 1000 base T. And as I said before, we've shipped more than 4 billion 100 base T and 1000 base T switch ports in the last 20 years. So we've set the scene already that we know what the cabling looks like, and we also know what the shipping of switch ports look like. So then we start to look at it, it's like, what can we do here? So what this chart is trying to tell you is the y-axis is really looking at the encoding, so I'll get there in a second, and the bottom axis is looking at the bandwidth we need in megahertz. What you're seeing here is that we have category 5E, which guarantees to provide you 100 megahertz at 100 meters with structured cabling. Category 6, which gives you 250 megahertz, and Category 6A, which is up at 500. So If we look at this, 1000 base T actually slides in and needing about 62.5 megahertz worth of bandwidth, at a Nyquist frequency, the best you could get. And the way they encode that is they encode that with 4 bits per second per hertz per pair. So that's what we've been shipping for an awful long time. That drives our enterprise access today. If we look at 10G base T, which we standardized in 2006, that actually needs category 6A cabling to get you 100 meters of structured cable, and it needs 400 megahertz. Now, it is using a better encoding. It's using a much more faster encoding. It does something called PAM5, actually PAM16. I'm not a PHY guy, so I get a little lost in the encodings. But basically, 10G base T is encoding more bits over the same thing with a better encoder, but it also requires more cost in the PHY implementation because you've got more DSP. So we have 1000 base T, which needs 66.5 megahertz, and then we need 10G base T, which needs 400. But what if we took what we knew about 10G base T, because we standardized that 10 years ago, and we know how to make that build. What if we took that and ran it at a quarter speed? I could basically slide 2.5G base T, pretty much with the same 10G base T encoding at 100 megahertz. I could then slide down 5G base T at around 200 megahertz. And what we're seeing is it's possible and technically feasible to get more bandwidth over the cable as exists in the world today. I want to thank my good friend George Zimmerman. He actually put together this original picture. Also, there's a white paper, and so for you guys who've pulled down the PDF, I encourage you to follow this link and see the white paper from the Ethernet Alliance, specifically on the spaces of base T, which talks about where base T fits in and how the encoding is happening. Okay, I'm going to change tacks a little bit right now. I'm going to talk about the NBASE-T Alliance. So the NBASE-T Alliance is a vendor alliance, right? Our job is to basically pull together a set of vendors from the ecosystem and advocate for and make progress towards deploying 2.5 and 5G base T. As you'll see over on the right-hand side, that's our current list of promoters from the website a few days ago. The promoters in the group are basically the people who sign up at the top level and drive the board. At the minute, that's Quantia and Cisco and Intel and Marvell and NXP, who are Freescale and Xilinx. Our contributor group who help us drive forward both the technical standards and the marketing material, and our adopters who are basically following along. So who's in the alliance, right? We try and get a full ecosystem. We have people who make components, people who make switching silicon, people who make systems like Cisco and Aruba. We have cabling people like Panduit, my sponsors for this one, and CommScope. We have test people like Fluke and Ideal. We basically try and put together the whole ecosystem because we absolutely know that we cannot deliver value to our users without taking all the ecosystem along with us. What's our role? We want to enable widespread deployment of this technology, which means we're going to evolve specifications, we're going to do interoperability, we'll do evangelization, we'll do trade shows. Our goal is to basically figure out how to get this technology, make it consumable, and put it in the hands of our users. I was talking ahead of this call, and I think the real strength of the Alliance is that we have a full ecosystem. That's one of the reasons why I was very excited and proud to be asked to speak to this group, because I think your part of the industry is critical to making the story work. Okay, I'm going to briefly go through this timeline. We started, and this is a little faded on my screen. Hopefully it's better on yours. You can pick it from the PDF. We started in October of 14, right? Clearly, there had been product development going on for a long time, but this was when the story became public, and became public both with the NBASE-T Alliance being launched and also with the start of the IEEE 802.3 process. So the Alliance was launched over in October of 14 with 4 companies, and we actually announced a physical aspect in November of 14. About the same time, IEEE 802.3 process got started because we had the call for interest in November of 14, which I co-led. Cisco basically shipped products, switching products. Actually, Cisco announced and showed switching products in January 15. In April of 2015, we actually exhibited at Introp. Around about May of 2015, 802.3BT, which is the 2.5 and 5G base T task force, got going. So we actually became a task force in April. That was in April in Berlin. And in May, we adopted technical baselines. What this means is between October 14 and May 15, we had got the industry together. We'd agreed on the problem. we'd decided how we want to deliver value to our users, and we'd settled our technical arguments. Right, so this was a massive step forward to being able to bring this to market in a timely fashion. So by July of 15, we actually had a first draft of our standard when we started our review of that. That was a very short period of time. In August of 15, we basically did our first NBASE-T Plugfest. In November of 15, at our anniversary, the Alliance hit 45 members. In January of 16, we actually finished this IEEE Untitled 3BZ, and we moved into what's called Working Group Ballot. That means that the task force, which is about 40 people who write the standard, said we're done, and we went on to the bigger Untitled 3 working group. We actually finished Working Group Ballot basically after 2 rounds, and we're now into sponsor ballot. And so we're currently expecting that the standard for Untitled 3BZ will be done in September of 2016. So I'll let you chew on that for a second, but that means that we have a IEEE Untitled 3 base T standard, which from start to finish is less than 2 years. So how do we get this done? We got this done by having a very clear picture of what it was we were going to do to serve customer need and deliver value, and we drove to that incessantly. So whenever it came down to a question of how to resolve an argument, we got back to how do we deliver customer value, how do we enable people to run their networks. And I think once you get agreement on that, everything else just falls into place. Okay, so let's look at some forecasts. So I didn't have time to put everything in because I have a lot of material, but if I had this chart for 8 to 11N to 11AC, what you'll find is the transition is quite fast, and in the next couple of years, they think it will pretty much all be 11AC. The more interesting transition for me is when the ramping of Wave 1 to Wave 2. So 11AC basically comes out in 2 waves. The first wave came out fairly early and was a little simpler, and the second wave is where we get most of the benefits. So Wave 2 introduces things like multi-user MIMO, and it fundamentally increases the bandwidth available from an AP. So the current forecast from Deloro, who I have to thank for some of this data, basically says that number crosses over around about 2017. So what we're starting to see is that we believe that 11AC Wave 2 will ramp very rapidly, and this will be driving bandwidth demand in the campus. Now, this could be a campus in a normal building because as you see people transitioning to open space, there are more people per square meter. Or it could be places that become interesting are places like universities where there's a lot of people in lecture halls, maybe in residence dorm where there's a lot of devices, or maybe places like healthcare where there are a lot of end devices. So what you're going to see is the ability to support a lot of people who natively connect wirelessly with many devices who expect great service. Okay, so let's look at the forecast for 2.5 and 5G-based-T. Again, this is data from Deloro from January of this year. What they're expecting quite a rapid adoption. So around 2020, they're thinking that there'll be around about 20 to 25% of the market will be 2.5 and 5G-based-T. Now, you could say that's a slow adoption, but this is an enormous amount of ports sold per year. If we get to this number, we've driven a major transition of the industry. Because as you can see, even today, we are still selling a significant portion of 100 megabit ports. So in summary, 11AC Wave 2 is ramping fast. The expectation is that 2.5 and 5G-based-T will be rapidly adopted. Let me quickly harp on some use cases. So the first use case you're going to see over here in the top left is added to 11AC Wave 2 APs. And I'm starting to describe this as the seed in the pearl. When Cisco started thinking about this, this was the problem we wanted to solve. We could see where APs were going. We needed an answer. What's interesting is once we deliver that answer, we can find a lot of other uses for this technology. I talked to you briefly about the access extension, the 3560CX platform we have. In this case, the uplink could be 10 gigabit fiber, and the downlink could be 2.5 and 5G-based-T. But I could also turn that around and use the 2.5 and 5G-based-T ports as uplinks with a gigabit on the downlink. So it becomes a very interesting way to build access extension into your network, and that shows up in places like conference rooms, in retail stores, in hotels, in cruise ships, and casinos. We are seeing a number of servers that could connect at higher speeds. There are a number of Untitled 3BZ NBASE-T NICs on the market today, and I expect more to come. because many servers or desktop computers can now push more speed. This becomes interesting for people who need more bandwidth, and it might be a content editing task, or it might be a research task, or it might be a CAD/CAM task. Anyone dealing with large amounts of data, they can often exceed 1 gigabit. Now we can give that to them at incremental project cost. Over on the bottom left, we have a really interesting use case that recently joined our alliance from a company called Pleura Technologies. Their focus is basically vision. They separate basically the camera, which is the sensor, from the processing node. So they have basically platforms for both gigi and for 10 gigi. What they find is a lot of their devices is that gigi is no longer enough bandwidth, and 10 gigi is either not available via cabling or is too much of an overhead. So they can now set up to offer systems that offer you vision processing over Cat5e and Cat6. So an example use case they might have, you could imagine that there would be a conveyor belt running through a factory. Over the top of that conveyor belt, they will have basically a camera, which is a sensor, and they'll connect it back to a processing device over BASE-T cables. The task of that camera is to monitor everything going down the conveyor belt and figure out what is in spec and out of spec and get rid of the out of spec stuff. So that's a really interesting use case where they need more than a gigabit, but they do not need 10. And NBASE-T gives you a way to size the end device and the network for what the end device needs. We also see a lot of people are interested from the bioscience research and tooling area. I talked to someone from a molecular biology lab with a very large instrument, and it basically it does an experiment and produces about 500 gigabytes worth of data. They're then transferring that over 1,000 BASE-T. They did not have the money available to recable. So giving them the ability to basically change the end devices and get a 2.5 or 5 times speed bump is going to enable them to work much more effectively. Okay, I'm going to go through this pretty quickly. So I just came back from Interop last week. This was the NBASE-T Alliance real network that we set up and had running on the Interop show floor. As you walk through this, what you're going to find out is that firstly we had cabling from both Panduit and CommScope, and I have to thank the people for sending along the people who could do a really great job of making the cabling look beautiful. But we also had switches and wireless from both Aruba and Cisco. We had evaluation cards from many companies. We had traffic generators from Spirent. We had test gear from Fluke. We basically had a full ecosystem. And the really powerful thing about this was to show people on the show floor that this is real, it's working, and you can see it. So what we're starting to see is this ecosystem is evolving rapidly to the stage where people can start to deploy with confidence. Okay, I'm getting close to the end of my time. Let me wrap up with a few final thoughts. So in the center here, you see where Ethernet started. Now, I'd have you think for a second about how impactful this has been to the way all of us work. If you took out the Ethernet network from our buildings today, you would still have wireless, but the rest would be a hollow core. So we evolved from the station and the transceiver and the tap and the terminator and the ether. Where have we gone? So the chart over on the top left is a chart from a Cisco white paper, which is basically showing how wireless speeds evolve over time. Now this chart is in the full version of my deck. What you're seeing basically is that that green line in the middle is 1,000 BASE-T, and you're seeing over time that the AP radio bandwidth level is just evolving way beyond that. Okay, over on the top right, I'm going to remind you about what's happening with our install base. Now clearly we want to recommend to all of our users when they build a new building to invest in the cabling for long haul, but we have to deal with the fact that there is this enormous investment for which we want to get more value. As I showed earlier, we know that we have the technical ability to put 2.5 and 5G BASE-T and make use of the current cabling that we have in the world today. And so the result of this story, the result of being able to assemble an ecosystem and a coalition of people, is that we now have our respected analysts predicting that we will get transition at a rapid rate to 2.5 and 5G BASE-T. So I think this is a great story because it enables all of our customers to evolve their network to meet their needs at incremental cost, right? Which I think is fundamentally us doing our job. Because all of our customers, they buy networks to run their business. And my goal is to let them run their business more effectively and better. So Ethernet is the foundational network technology of the world. It makes everything run. So there are a few links here. I'm sorry, one of the links got hidden. I encourage you to pull down the PDF and then go and take a look at these links, get educated, and reach out if you need more information. With that, I'm done, and I'd like to hand back to Patrick.
Peter, thank you very much. Thanks for that information. I will remind members of our audience that you can use the purple button at the bottom of your screen to submit questions. Thanks to those who have submitted questions already. Feel free to do so as we continue. And we will continue with Tom Kelly of Panduit, who's going to address the characteristics of the twisted pair cabling systems that support the 2.5 and 5G BASE-T systems that have been a point of discussion. So Tom, whenever you're ready.
Thank you, Patrick, and thank you to Peter for that great introduction on the compelling market needs behind 2.5 and 5 gig and the potential that our end users can get from moving their networks in that direction. So what I want to review with everyone today is TIA's TSB 162A and TSB 5021, and then the impact of these new standards on cable performance, how people can assess the cable plant, power delivery to access points, mitigation strategies, and finally some resources, much as Peter provided at the close of his presentation, for additional information. I think it's very interesting when Peter reviewed the timeline of this standard that it's moved quite quickly. And so I think providing that additional information for all of us to get familiar and understand the applications and embrace the technology is very important. So I'll start with a review of TSB 162A, which is cabling guidelines for access points. So in this graphic, we see a typical commercial enterprise divided into square grid sections, approximately 60 feet by 60 feet. In the highlighted area, you see a meeting space or collaboration space. Typically, we see higher bandwidth demands in that space and should really be focusing more on the increased number of access points in order to service user density. The way this TSB was broken up was really more about coverage and how do you provide uniform coverage across the enterprise. I think it needs to evolve really more to talk about the user density or device density as the enterprise matures. You see now today, the device count is certainly going up. All of us are carrying around many more devices than we were when wireless was more in its infancy. It's common to have certainly a laptop, a mobile device, e-readers, tablets, phones, things like that. All those things are really pushing up the device count and making things more demanding in the wireless space. With 802.11.AC, access points need higher bandwidth, and Peter correctly described how bandwidth requirements more than a gig are becoming common at the access point. So if we take another graphic of a typical enterprise deployment and we imagine the green squares as where the access points would be in a corridor or in a hallway, and then you see a specific access point overlay into a conference room. These grid sizes of roughly 60 feet by 60 feet would result in a layout something like that. Now, if we look at the cabling runs going to these access points coming from a telco room, you would see the TIA recommendation is 2 Category 6As to an access point in a greenfield. But if you'd imagine how these cable runs would build out, you see these concurrent runs of cable, and this bundled length is something we're going to talk more about in a few slides. So it's of importance that we pay attention to that bundled length of cable and how your access points are deployed across your enterprise. And you see, when we get into the risk mitigation and assessment, that bundled length is going to become more and more important. So don't forget about that. Now, a review just at the category level and the differences between the category classes. When we went from category 5E to 6, as Peter described, the bandwidth more than doubled from 100 megahertz in the standard to 250 megahertz. There were also significant improvement in some electrical parameters internal to the cable's performance, like near-end crosstalk and attenuation to crosstalk ratio at the far end, and return loss. So all those cable internal parameters are important improvements from 5E to 6. When we went to category 6A, that's the first time the industry really addressed alien crosstalk. And alien crosstalk is shown in the graphic there with 6 surrounding disturbing cables around the victim cable in the center. Now, those parameters were very important and instrumental, and part of what made Category 6A challenging was that alien crosstalk. And so we're going to have to bring that alien crosstalk terminology with us into the implementation of 2.5 and 5 gig, and we'll talk more about that. But in a little bit more detail, alien crosstalk is important because it's very difficult for the PHY and the elements internal to the channel to compensate for any external noise elements. And so that's what makes it such a critical parameter and difficult for the active equipment to deal with. And that's why it has very specific requirements in Category 6A on the level of alien crosstalk that's allowed. So now if we look at more detail in the TSB 5021, which is titled, Guidelines for the Assessment and Mitigation of Installed Cabling to Support 2.5 and 5 gig, they're expecting completion in early 2017, but as they've been working through the standards process, there's significant information available that we're going to detail now. Really, these requirements are for how you can use existing 5E and 6 cabling to deploy 2.5 and 5 gig applications. For clarity's sake, we're going to divide this conversation into 2 components. The first one really being internal requirements, which are common test parameters that we're all familiar with today, again, relating to near-end crosstalk or NEXT, ACR-F, return loss, and insertion loss. The 2.5 G-base-T uses the Category 5E requirements. The 5G base-T extends those 5E requirements up to 250 megahertz. So if we look at just the internal parameters in a table and we assess whether or not our cable meets those internal requirements, let's start first with that 2.5 G-base-T application. From an internal perspective, installed Category 5E, 6, and 6A, we don't expect any challenges with those as long as quality product is installed by quality technicians. If we look at 5 G-base-T, certainly if you're installing Category 6A, there's no risk at all, and that's certainly what we would be recommending for any greenfield installations. Category 6 also is expected to have no issues at 5 G-base-T in a typical installation. Category 5E requires a little bit more attention because the 5 G-base-T frequency requirements were beyond what the 5E category requirements were when that cabling was made and specified, and hence why it's shaded in yellow. Really what it means is there's more assessment required on the internals. So internals are part of the story. As I mentioned earlier, we know we have to assess also the external requirements, and the graphic there is just a reminder about alien crosstalk and some of the challenges around alien crosstalk. So now we have a new term to introduce. It's a technical acronym that we're all fond of. ALSNR is the new measurement. It stands for Alien Limited Signal-to-Noise Ratio. And to try to clarify it, essentially it's the ratio of alien crosstalk or external noise to the insertion loss. Testing and research shows that it's a better prediction of PHY performance. It's certainly more difficult to meet for 5G base-T due to the increased bandwidth and frequency. There's more alien crosstalk, and that makes it a little bit more challenging to meet. This ALSNR limit is added to the drafts of the 802.3BZ and the TIA TSB 5021. The way it was developed was from industry-wide testing from multiple industry-leading companies, like those on the call and others, to validate the test setup and the test method and the thresholds. And again, as we're trying to do our best to expand the information base, if you're looking for the more detailed explanation of the noise levels and the testing methodology, they're contained in the links below. They are rather technical. And most importantly, in order to ensure that we meet the application requirements, both the internal and the external requirements, including ALSNR, have to be met in order to ensure that we can deliver the multi-gig performance that we're expecting. Now, when Alien crosstalk was not thought of or in the design spec when we originally considered Category 5E and 6, but now when we look at our new assessments and we put it in a tabular format to help clarify things, in this graphic we see in black in the upper left the bundled length being less than or equal to 50 meters. So if the length of the cable that's bundled neatly together is less than or equal to 50 meters, for both Category and 5E and 6, it's low risk. Certainly for Category 6A, it's no risk because it's already developed to work at very high frequencies and support infrastructure at more than a gigabyte. So again, the important piece to look at there is highlighted in red. It's that bundled length during your risk assessment. So when you're trying to determine if your new access points can use existing infrastructure, that bundled length is a key criteria. Now, if we look at bundled lengths between 50 and 75 meters, you see the shading representing whether or not it's low risk or medium risk here. So you see 2.5 and 5 gig, slightly more risk on 5 gig over 5E, and again, no risk on Category 6A. So you see, as the bundled length goes up, you'll definitely see a trend that the risk elements in the assessment need to go up. And we'll, at our conclusion of our time today, we'll talk about some of the mitigation strategies that you can use if you believe the risk is high in application. Now, the bulk of cabling installed in the world is likely bundled distance less than 50 meters. And so you see, if we looked at those billions of meters of cable installed and the billions of ports, the majority of those ports would stay in that 50 meter or less bucket. There'll be some bleeding over into the 50 to 75 meter bucket, and then that 75 to 100 meter bucket, which industry data tells us is probably the smallest of those three buckets. But now we assess here again, Category 6A would have no risk because it's fully capable of multi-gig applications up to 10 gig. For 2.5 gig, you see, some medium risk, and then on Category 5E with highly bundled long runs of cable, that's really where the most risk is. And so we'll talk a little bit more about that. Just a reminder, though, that bundled length is really, the summation of bundled patch cord and horizontal cable length, and it likely in an installation, out into the floor of the enterprise, it's not 100% bundled cable all the way to the end device. And so that's part of the assessment criteria that the end user or installer contractor needs to do when determining what the application risk might be. And again, just a final closing comment that you see on Category 6A, there's no risk in any of those applications, and that's what certainly we would be recommending for greenfield installations. So just a clarification point about performance matters. So when that original cabling plant was installed, what was originally selected? Not all cabling and connectors are created equal. This is certainly evidence for why you'd like performance levels being above standard compliant, because that margin that was available when the cable was initially installed could pay dividends and reduce the risk assessment that needs to be done when you move through these other categories. How long has the existing physical infrastructure been installed also matters. If you have, a difficult installation that's been in place for many years, that may elevate your risk profile. How was it originally put together and the quality of that installation? And then finally, that bundled length criteria that we talked about earlier, the increased amount of bundling does raise the risk profile during the assessment. So that's a key item to review. And, in summation, minimally compliant products will not perform as well as those with built-in margin. And so just for reference sake, we've included an example of guaranteed channel headroom margin above the standard and why that can pay dividends for you on your multi-gig applications. because it allows more flexibility and capability than perhaps a minimally compliant installation. Now, how are these access points going to be powered? I think, as Peter mentioned, there's tremendous growth in these access points, and PoE is the preferred method to deliver power to these. And you see a forecast here by BISRIA on the tremendous growth rate in that orange line on the percent of access points being powered by Power over Ethernet, which again is a great opportunity to lower the installed costs. You no longer have to run a separate power circuit into your enterprise for the access point. You can use one cable to deliver both data and power to the access points. So we expect to continue to see that trend continue to accelerate. By 2020, it's expected that the vast majority of these devices will be getting their power over Ethernet, which isn't horribly surprising. Now, this table summarizes in a little bit more detail the types of PoE available and the rate of change from 2003 to 2009 in PoE and PoE Plus and UPoE from Cisco that's shipping today. The new PoE standards, really allow a tremendous amount of additional capability and new devices, as Peter mentioned, Cisco's digital ceiling initiative, all providing avenues to take advantage of this increased power delivery through Ethernet, which is exciting for the entire industry. Now, as we talked about cable bundling to the access points and why that was important, you'll see it come up again here in PoE delivery. So if we talk about the highest power PoE standard covered under TSB 184-A, the PoE++ Type 4, you see the maximum number of cable bundles allowed per the standard. The reason why we have those restrictions is because the cable can get quite warm under delivering that amount of power load, and as the bundle counts get very high, the center of that cable bundle can raise more than 15 degrees Fahrenheit, which is the max allowed by the standard. So again, cable bundling, both for 2.5 and 5 gig and PoE, is going to be a kind of an additional focus point for end users and installers going forward that they typically didn't really have to worry about in the past. And I think many people really enjoyed, and Patrick's website's done a great job posting pictures of very beautiful cable management of all these tightly bundled cables and how fantastic they look. Well, from a performance standpoint, when you get into high power PoE and 2.5 and 5 gig, there's some potential concern with that tightly bundled cable all the way from source to end device. On the right-hand side, you'll see Panduit's values listed for PoE++ maximum bundle counts. And just like when we were talking about electrical performance above the standard, there are some vendor-specific capabilities of offering up additional performance and how it can allow larger bundle counts. And of particular note, on Category 6A, where we use our matrix tape to improve our Alien crosstalk performance, it also helps substantially improve the thermal performance of the cable and allows significantly larger bundle counts. So again, performance above the standard is possible and does allow additional flexibility. So now some recommendations for NBASE-T deployments. At many points during the conversation today, we've talked about using Category 6A increases the maximum lifespan in the enterprise for your cable plant, and we're seeing strong growth rates as users migrate to that because it gives them the most flexibility. In brownfield and existing installations, if you're using Category 5E and 6, you'll see some recommendations like unbundling your telco room patch cords or replacing those patch cords with Category 6A can help mitigate your risk. You should assess your existing cabling per the TIA TSB 5021, which we've reviewed today, where we look at the total length of the channel, the bundled length, and the performance rating of the cable and whether or not it had existing headroom. And then if concerns still exist, there's other things you could do, like testing cable to the 28 dB ALSNR that we detailed today, we could unbundle sections of the horizontal cabling or replace the horizontal cabling to Category 6A. You see those are listed kind of in levels of increasing severity for whether or not an end user would likely consider doing any of those things. But those are the steps that we would recommend you investigate as you move through these. And then finally, just as Peter elegantly summarized, with additional resources, we have some here listing the 802.3 BZ standard, the TSBs of reference that we've covered today, the NBASE-T org website, where we'll soon have a white paper detailing out this process. And I'd like to call some attention, as Peter mentioned, George Zimmerman will be doing a fall BICSI presentation on deploying NBASE-T technologies, so we're looking forward to that. And then a technology brief that we've written on more detailed requirements and how you can address some of these deployments. And with that, I'd like to turn it back over to Patrick, and we can accept some questions in the remaining time.
Tom, thank you very much. Before we get underway with questions, I'll just very quickly let members of our audience know that if you can use an attendance certificate from today to earn a BICSI continuing education credit, you will find that certificate behind the yellow button on your screen. We've mimicked the set of buttons on your screen here. On this slide, the yellow one, second from the right, should be where we have hidden your attendance certificate. A click or two should get you there. So thank you very much for that information, Tom, and Peter as well. And we do have a number of questions lined up that I'd like to get underway with. And I'm just sorting through them now. So I will, okay. I'm going to put this one out there if Peter or Tom is available to answer it. A question asks about, do you see or do you not see additional security video ramping and absorbing bandwidth as well? I wasn't sure if, Peter, that one was directed at you, but if it's something that you could chime in on, but it certainly was something that came from our audience.
So let me give that one a go. I need to be a little careful, because if you're just doing a simple IP cam, right, those don't take very much. I think the video, you need to be looking at something like the Gigi Vision, where they're actually doing a sensor. So it really depends on the type of video stream, right? A basic IP cam is pretty small. But if what you have is something like it's a high resolution uncompressed video, that's interesting. So I think there's going to be lots of applications, and I think once you enable people to use more data, some of those applications will evolve.
Got it. Another question that I think was aimed at you, Peter, asked about the sort of the ecosystem, and you mentioned some of the cabling vendors that are in the NBASE-T Alliance, and I'll try to tactfully put forth the question. Okay, but some of us make a living by selling cable, right? So how does the entire ecosystem benefit if it appears that the commerce of cable is kind of being taken off the board by some of these technologies?
So this was a conversation we had to have early on, and I'll try and be respectful and honest, and Tom can chime in. From what I can see in general, the cabling industry has done a great job of selling 6 over 5E when 1000-base-T was all most people needed. And so the way I would see this is we're now getting to the stage where it's possible to incrementally upgrade buildings. And so when people see value over the cabling that's moving, and they're looking at a 10-year plus horizon, then it makes sense to sell the next better cable. So we're seeing that ADIT 11AC Wave 2 is going up to 5 gig. 11AX wants to go faster. I think when we start to see the evolution device at the edge of the network that need and can consume more data, then I think your ability to sell the cabling, which is going to serve needs for 10 to 15 years, is enhanced. Does that make sense?
Yeah, that makes sense to me, Peter. And I would add to that, I think for us, somewhat ironically, we've seen wireless AC really be the first multi-gig application in the enterprise, and certainly for greenfields, we have many customers that now view that Category 6A being installed as the common backbone or infrastructure in the enterprise, being a decision that they're willing to make now. I think we've all been positioning Category 6A for some time, but it was missing perhaps some of that linkage to an immediate application in the enterprise. And ironically, for the cabling industry, I think wireless is probably that first multi-gig application in the enterprise that's causing people to really consider the lifespan of their infrastructure choice. And by putting 6A everywhere, they can drop in access points, cameras, whatever they need when they need it. They get the best PoE performance. And all those things, I think, in a greenfield are clear drivers towards Category 6A. So I view that as a big momentum in the positive direction.
Thanks very much to both of you. Another question that you both may have an opinion on. Tom, I believe it was directed at you during your presentation. Short question, but maybe not a short answer. Why 2 cables to a WAP, to a wireless access point?
Yeah, I think it's because of best practice, and as Peter said, the rate of change in wireless standards is quite high. So every 3 or 4 years, you're seeing a new wireless standard come out, and it's very laborious to add cable to an existing building. And so putting 2 6A cables, let's say, to an access point really gives you that ultimate flexibility to, let's say, split those cables in the future, or have redundancy, or have one for power and one for data. You know, when the walls are down is really the time to prepare yourself for the future. And with wireless changes coming so quickly, I think it's more of a mitigation strategy and kind of a best practice, if you will, more so than it's multiplexing data across 2 cables to 1 access point today.
Peter, did you want to chime in, or I could certainly move on to others?
Yeah, so I think there's a great benefit in general being able to deliver everything over a single cable, but I also go with Tom's comment that you have to do some pre-provisioning, because we know that the incremental cost of an extra cable, that install time is small, but going back later is really hard. And so I think there's some uses for having that. Yeah, I think I'm done with that one.
Right. Understood. Another question that was aimed at Tom asks, can you mitigate some risk assessed by cutting cable ties and loose laying the cable?
Yeah, that's an excellent point. As we talked about unbundling the cable, like a patch cord inside a telco room, or portions of the horizontal run if you can get to it. Yes is the short answer. So un-Velcro tying or uncable tying that cable bundle and spreading those cables out does reduce that alien crosstalk risk, and distance helps, right? I mean, I think that's when the industry first deployed Category 6A cables, and they were quite large. You know, people were using airspace as a mitigation technique from alien crosstalk, and that technique, you know, still is valid and works today. So those unbundling techniques are exactly what would be required to mitigate some risk for the portion of the horizontal or patch cable that you could reach.
And Tom, I appreciate you mentioning that our magazine, our website has showed some of the beautiful cable management that has taken place. I will tell you that we've gotten many comments over the years along the lines of those pictures look terrific. I'd like to see you go back in 6 months and take a picture and see what that place looks like. So understood that sometimes unbundling happens intentionally, and sometimes by less fortunate circumstances. But understood for sure. Actually, if Peter's on still, one question asks if you can kind of clarify difference between NBASE-T, the NBASE-T Alliance, which we've discussed here, and then 802.11bz. Are there one and the same? Is there a difference? NBASE-T, 802.11bz. Can you kind of draw a line between them if there is one for us?
Sure. Well, so firstly, there is a miscommunication. So 11AC is the wireless standard, and 802.3bz is the wired Ethernet standard. So NBASE-T Alliance is a vendor organization, so we have a specification. 802.3bz is the standard that comes out of Ethernet, out of 802.3. In terms of actual technical differences, the 802.3bz group is a different group of people, right? Actually, they're almost the same people with a different role, but their Ethernet specification is based on the technology out of the NBASE-T specification. And in the long term, NBASE-T has a few things above it. So they're a cooperative group of people. All of the people running NBASE-T is a different set of people with some different rules, but we're trying to push the ecosystem and promote the 802.3bz standard. So these are not competing standards. Does that help? Is that clear, Patrick?
It is. Thank you very much. A question that I think is aimed at Tom asks about the potential use of a cable sock as a mitigation technique to combat alien crosstalk, talking about a cable sock as opposed to something like bundling cable with plastic ties or with hook and loop wrap type techniques. So is the cable sock a viable option?
I think it would depend how tight that cable sock is. We call them, I believe generally we call them expandable sleeving or looming of a cable. I think it could be a concern. It depends the tightness of the sock or sleeve and the amount of the cable that's covered in the sleeve. I think anything that keeps that run of cable, in extremely close proximity and long parallel length could be too much work to remove that, in the field. So I think it should be viewed similarly to Velcro ties or cable ties, I think.
Thank you, Tom. The final question before we sign off asks, are there any testers with 2.5 and 5 gig software applications or capabilities to conduct tests?
So I want to show with this audience, what sort of test are we talking about? Because when I'm talking in my world, this is something like a Spirent or an Ixia. But in your world, it might be something like a Fluke, and I'm not sure which one I'm answering for.
Well, if you, I'd say the Fluke and Ideal, I understand, are members of the NBASE-T Alliance. I think that's the sphere in which the conversation's directed.
So Fluke had their tester running live in drop last week. Spirent also have their tester on my side of the house. So the answer is that there is some test equipment available, and more is coming.
Excellent. Thank you. Thanks very much for those answers.
So Patrick,
and
there was one other question that came up, which I'm not sure if you want to deal with.
Please do, Peter.
This was from Ken at Greenlee about existing enterprise installation, maybe a mix of 5E and 6. And I don't know if Tom wants to take a look at that one. It came in at 10:37. Because it gets down to requalification or as BERT, and I'm not sure I can answer that one.
Yeah, I think that one, Peter, might be detailed enough. I'll respond in email directly offline.
I think the point we want to make here is that there's going to be a lot more detailed follow-up questions that we have, and so I think this is the start of a conversation.
Yeah. Okay, I would agree. I think it's probably going to be pretty detailed.
Excellent. Thank you again. Appreciate, of course, the expertise provided here today by Peter Jones and Tom Kelly. We appreciate Panduit's sponsorship of this seminar, and certainly are very appreciative of the members of our audience who joined us today. So on behalf of Cabling Installation and Maintenance, we thank everybody, Tom, Peter, Panduit, and of course our attendees for today's event. We wish you all a good day. Thank you again.